Welcome back to the deep dive. Today we're digging into something pretty significant. Anthropic's latest frontier model, Claude Sonnet 4.5.
hmm
And, the sources we've been looking at, Data Pro News included, they're all circling around this really pivotal question, one that should probably be keeping data leaders awake.
Right.
Is this just, the next small step, an incremental upgrade? Or are we actually seeing something bigger, a fundamental shift in how companies handle their data, their governance?
Yeah, it's definitely looking like the second one. The consensus out there, especially among the governance and engineering specialists we read, is that 4.5 is really a strategic inflection point.
An inflection point. Okay.
Yeah, it's like the technology crosses this threshold, this capability line, and suddenly the old ways of thinking about risk, they just don't really cut it anymore. You need a reevaluation.
Yeah.
So our mission today, really, is to get past the marketing buzz and unpack why data leaders are calling this a game changer. And maybe even more importantly, how this this aggressive autonomy changes the risk profile for, frankly, every data engineering team out there.
That distinction is crucial, isn't it? Because for, the last couple of years, we've settled into this idea of AI as a helpful co-pilot.
Exactly, the helpful assistant model.
It sits there, suggests some code, maybe finishes your thought.
Right.
But you're still the one firmly in control, holding the wheel.
Yeah. And the immediate kind of pressing takeaway from all the analysis seems to be this model moves beyond that. We're shifting gears from the co-pilot era where, the human starts things and the AI helps out,
Right.
into one where the model is more like a controlled autonomous component. That's the phrase the sources use.
Autonomous component.
It doesn't just help you write the logic. It
Yeah.
can design, run, and even maintain the whole workflow itself.
Okay, let's definitely unpack that. So when we say moving beyond the co-pilot, we really mean a different scale, a different scope altogether, right?
Totally different.
Your co-pilot might help you write a tricky SQL query,
Mm-hmm.
but this autonomous component, you give it a high-level goal, maybe something like implement the new data retention policy, and the expectation is it does the whole thing.
Pretty much. Scoping, coding, testing, deploying without needing you to intervene at every single step. That's the vision.
Wow.
And it's that ability to handle these long, complex, multi-step jobs while keeping track of everything, maintaining coherence and context that really makes 4.5 feel less like an assistant and more like a true agent.
We're not just talking about linking 3 steps together here.
No. Think complex processes, things that run for hours, maybe even days. Intricate stuff.
Yeah, the sources really drove this point home with one example that, frankly, it kind of floored me.
You mean the chat application?
Exactly. The model gets a high-level prompt, and then it just independently generates a whole working chat application.
That's the one. A complex app, something like Slack or Microsoft Teams in terms of scope.
Okay.
And here's the kicker, the detail that really defines this new level of autonomy. Over 11,000 lines of code, generated without human intervention until the task was marked complete.
11,000 lines. That's not just filling in blanks.
No, this is full-on autonomous software development at an enterprise level of scale and complexity. Yeah, it's a big deal.
So if we map that capability, that 11,000 line potential, onto the world our listeners live in data pipelines,
Right.
this starts to sound like a solution for some of those really nagging, long-running problems, doesn't it?
It does. That capacity for long context, keeping track of things over time, it's something data engineering teams have been, desperate for.
So what are the prime targets?
Well, the specific applications that keep coming up are naturally multi-step and need a lot of context. Think complex regulatory compliance checks.
Yeah.
The ones spanning dozens of different systems.
Yeah.
Or large-scale data cleansing jobs, the kind that need adaptive logic as they go. And maybe the biggest one, automated pipeline orchestration.
Orchestration, so not just writing a single transformation.
Exactly. It's moving towards managing the whole flow, the infrastructure, the data movement, the transformations, the whole life cycle.
Okay, but that scale, that ambition,
Yeah.
generating 11,000 lines of working code autonomously, it kind of begs the question, how good is it really?
Fair question. Essential question, actually.
We need more than just the cool anecdote, right? We need to know how reliable this thing actually is if you were to put it near production data.
Absolutely. And this isn't just talk. The numbers are why this becomes a strategic thing. We really need to focus on these things called agentic coding evaluations. Agentic coding. Yeah, they're specifically designed to measure how well the AI can autonomously build functional software, from start to finish.
All right, hit us with the stats that would matter most to a data team.
Okay, so In these core agentic tests, Claude 4.5 nails a 77.2% success rate, which is already pretty remarkable.
77%. Okay.
But here's where it gets really interesting. Anthropic used this technique. They call it parallel test time compute. And when they applied that, the success rate jumped to 82.0%.
82% success on autonomously developing working software. That's huge.
It is.
But hang on, that term parallel test time compute sounds a bit dense. What does that actually mean for how it works? How should we understand that jump?
Yeah, good point. Think of it like this.
Yeah.
Instead of the model generating just one potential solution to a complex problem and then trying to debug it step by step,
Okay.
it actually spins up, say, 3 or 4 different solutions in parallel simultaneously.
Okay, like multiple attempts at once.
Exactly. Then it uses its own reasoning ability to kind of compare them, figure out which one is the most robust, the cleanest, the most likely to work before it gives you the final answer.
So it's like having a mini team of developers attacking the problem and picking the best outcome.
That's a great way to put it. And it leads to more reliable results.
That makes sense. And these benchmarks, they're measuring the ability to create production-ready data logic, right? Without a human constantly intervening.
Precisely.
This could really change how teams budget their time, couldn't it? Less time on the grunt work of writing and debugging basic ETL or ELT routines?
That's the potential, yeah. Those routines eat up so many hours.
Okay, so coding is one thing. What about interacting with, well, the rest of the world, other systems?
Right, that's another big piece. Look at the general computer use benchmarks. It scored 61.4%.
61%. How does that compare?
It's a really significant jump over its predecessor, Claude Opus 4.1.
And that general utility score, what does that mean in practical terms for businesses, especially those with older systems?
It means a lot. Think about that ancient, clunky ERP system maybe lurking in your organization.
We all know one.
Right. The one where someone has to manually click through 7 different screens, fill out forms, just to get some critical piece of data out.
Yep.
That 61.4% suggests the model can handle that. It can interact with external interfaces. It can effectively read a terminal screen, navigate complex UIs, automate filling out forms, stuff that used to absolutely require a human operator.
So it could potentially bypass the need for building expensive custom APIs for those old systems.
That's the implication, yeah. It could be a game changer for data integration with legacy tech.
Truly revolutionary if that holds up. What about the quality of its analysis? Can it reason about data?
Yeah, one of the reports we looked at really hammered on its structured reasoning. They found exceptional performance in things like complex financial analysis, risk assessment, detailed portfolio screening.
Right.
Industry analysts are starting to use phrases like investment-grade insights that require less human review.
Less human review. Why?
Because the improved structural reasoning seems to cut down significantly on those typical AI issues like hallucinating numbers or making logical errors when processing numerical data.
Yeah.
It's moving from just being a source of ideas to being a more trusted analytical partner.
Okay, but here's where things take, a more serious turn, right? Because these capabilities sound amazing, almost sci-fi.
They do.
But every source immediately pivots to the flip side, this idea of a profound risk profile.
It really is the definition of a double-edged sword. That ability to autonomously pump out 11,000 lines of code overnight. It's a massive productivity boost, no doubt.
Oh, cool.
But it comes hand in hand with the potential for, let's just say, catastrophic corruption of vast amounts of production data. That's the language being used.
We need to make that risk concrete for people listening. What's the nightmare scenario that governance experts are worried about here?
Okay, let's paint the picture. Imagine you task an autonomous agent with optimizing your main customer data pipeline. Let it run overnight. It processes terabytes of customer information, implements dozens of new transformation steps it designed itself. Now, what if that agent introduces just one subtle logic flaw?
Right.
Like maybe an incorrect data type conversion, or it makes a hidden assumption about how text is encoded. Something small, easily missed.
Right.
That flaw, operating at AI speed, doesn't just cause a small error. It propagates instantly through your entire data ecosystem.
It's not just the mistake, it's the speed and scale of the propagation.
Exactly. It's like a silent data contamination. If a human makes a similar bug, the damage is usually limited by how fast they can deploy, the manual checks, the review cycles. When an AI designs and deploys a whole new infrastructure in, say, 3 hours flat, the potential scale of damage just explodes.
Yeah.
You could corrupt a major customer data set completely before anyone's even had their morning coffee.
So the traditional ways we check for quality, manual code reviews, slow, methodical testing stages, they just seem completely outmatched by this speed.
That's precisely the problem. Our QA processes, they're built around human speeds, human error patterns, human development cycles. They rely on checks and balances designed for us.
Yeah.
When you have AI generating systems at this scale and velocity, the clear consensus from governance specialists is you absolutely need stringent supervisory controls. But even more fundamentally, you need robust, immediate, transactional rollback mechanisms.
Acceptable.
Without that safety net, the sources suggest you're basically flying blind at incredible speed,
Yeah.
operating on borrowed time.
Okay, so if the risk is that high and our usual safety nets are, well, full of holes when it comes to this speed, what's the answer? What did Anthropic actually build in to make this usable for enterprises?
Right. This is where their checkpoint capability comes into play. The sources really highlight this as the key piece, the architectural linchpin enabling controlled autonomy.
Checkpoint. Okay, how does that work?
Think of it as a really sophisticated system-wide undo button or restore point that works during these autonomous operations.
An undo button for the whole data process.
Essentially, yes. The crucial part is that administrators can define these checkpoints at critical moments in the workflow, high-stakes moments.
So what does setting a checkpoint look like for an admin? What are they actually doing?
It means marking a specific point where verification is absolutely required before proceeding. For instance, maybe right before the autonomous agent tries to merge newly processed data into the main production environment.
Okay, a critical gate.
Exactly. The admin mandates a checkpoint, let's call it. Schema check passed and data count verified. Now, if the agent goes past that point and then some error detection flags a problem, maybe a compliance rule is broken or data looks weird, the entire operation can be instantly rolled back,
Right.
wiped clean. Everything reversed to the state it was in at that last verified checkpoint.
Ah, okay, so it contains the potential damage.
Precisely. It completely changes the risk calculation. You go from this terrifying all-or-nothing gamble
Right.
to what the sources are calling graduated autonomy.
Graduated autonomy. I like that.
It's autonomy on a leash, maybe? It gives you a built-in safety cord. It doesn't stop the AI from potentially making an error.
But it stops the error from spreading uncontrollably.
Exactly. It limits the blast radius and, importantly, makes the whole system immediately recoverable. It becomes a controlled, auditable, autonomous process.
This sounds like it also forces a shift in how we even design data architecture, doesn't it? We're used to these rigid pipelines. If step A happens, then do step B.
Absolutely. The sources talk quite a bit about moving beyond that towards what they term intelligent pipelines.
Intelligent pipelines, meaning?
Well, traditional pipelines are kind of dumb, right? They do the same exact thing every single time, regardless of the data.
Yeah, pretty much.
An intelligent pipeline, powered by something like Claude 4.5, with its ability to maintain context and reason, could actually change its own processing logic on the fly, based on the characteristics of the data it sees during the run.
Whoa, okay. Can you give us a quick picture of what that looks like?
Sure. Imagine a huge data file comes in. A traditional pipeline might just fail or throw a bunch of errors if it suddenly hits way more missing values than usual.
Right, it breaks.
An intelligent pipeline, though, could potentially detect that sudden drop in data quality, say, hey, there are 30% more nulls here than expected, and then autonomously trigger a specific secondary data cleansing routine designed just for that scenario.
Without a human intervening.
Exactly. It handles the anomaly, cleans the data appropriately, and then continues with the main transformation steps, all automatically.
That's a huge leap in operational resilience. And circling back quickly, that general computer use skill we talked about,
The 61.4% score.
that must unlock some serious potential for integration, especially with those legacy systems again.
This is where things get really practical and potentially very exciting for companies. You might not need to spend months or years building custom connectors anymore.
Because
Claude 4.5 can interact with screens like a human does. It can literally engage with those old, clunky legacy system interfaces directly.
Navigating menus, filling forms.
Exactly. This could genuinely revolutionize how you get data out of older systems that have just been sitting there locked away because they lack modern APIs. You could potentially unlock trapped enterprise data almost overnight.
Okay, so let's pull this all together. What does this mean for you, the listener, who might now have access to this incredibly powerful, autonomous agent capable of churning out thousands of lines of production code?
Well, The verdict from the sources we reviewed is pretty clear and consistent. Claude 4.5 represents a transformation, not just a simple evolution.
It's a step change.
It really seems to be.
Yeah.
And the competitive advantage for companies that get this right, that move early, it looks significant. Early adopters are already reporting big improvements in how fast they can develop things, how efficiently they operate.
But the big but remains governance, right?
Absolutely. That's the central challenge. Data leaders simply must fundamentally rethink their governance frameworks, their QA protocols, their change management processes, all the things designed for human systems.
And inevitably, the question executives will ask is, how does this stack up against the competition? GPT-4o, Gemini.
Yeah, that's a natural question. Interestingly, the sources we focused on for this deep dive were very centered on Anthropic's specific capabilities. They didn't really draw direct feature-by-feature comparisons with other models.
Okay.
But they did clearly position the ability to handle high-stakes, long-running autonomous tasks with mechanisms like Checkpoint as the critical strategic differentiator for enterprise use right now.
So the safety aspect is key.
It seems to be the argument, yes. The takeaway is that the investment has to be in the technical safeguards first before you unleash this kind of power.
Which means, practically speaking, investing in things like really solid version control and actually implementing those comprehensive rollback capabilities, like now, not someday.
Exactly. The advantage will go to the organizations that successfully manage this transition. They'll get the faster development cycles, yes, but they'll also gain the ability to tackle data problems that were just too complex or too risky before.
So the window to position yourself strategically is open.
It is open, but the sources are pretty emphatic. It's finite. The speed of this autonomous AI evolution demands an equally fast adaptation in how we govern it. You can't wait.
That's a fantastic summary, pulling together both the immense opportunity and the, frankly, quite sobering risks. Thanks for walking us through all that dense material.
My pleasure. It's fascinating stuff.
Before we sign off, here's a final thought for you to chew on this week, building on everything we've discussed. Given this model's power to autonomously generate complex code A&D, interact directly with legacy systems, maybe that ancient ERP system you have, what specific part of your data governance framework, going beyond just code review, do you think needs the most urgent reimagining in your organization? How do you prepare for AI operating at this kind of speed and scale? Lots to think about there.
That's it for this deep dive. We'll see you next time.